So what we're going to do is we're going to continue with lesson 5. We're going to finish this problem here. And we said, hey, we don't like negative exponents. So we found out that since they're added and subtracted on top, or added in this case, they're not all multiplied and divided. So therefore, I had to bring them all to their own denominators, or their own basement, I call it, to get rid of negative exponents to make them positive. And so, when I did that, I created 3 separate fractions within a larger fraction, which is called a complex fraction. We don't like complex fractions, so we want to get rid of it. And so that's where we started leaving off yesterday, was saying, hey, complex fractions can be easily handled by multiplying everything, or the top and bottom, numerator and denominator, by the LCD. So we said, first, factor, and then we start looking at all those denominators. That's all in the video from last time, and we covered it before. So now we're to the point where we said, hey, we got them factored. You wrote down the first denominator, which is x squared. We now move on to the second one. The second denominator is y squared. Is y squared part of x squared? No. So therefore, I need a y squared. We then look at xy. Is x part of x squared, y squared? Yes. X squared is x times x. I already have an x. I'm good to go. What about a y then? Yes. So therefore, x squared, y squared is the LCD of our problem. The last step, or the last major step that has its own smaller parts to it, is to multiply the top and the bottom of this fraction by that LCD. And so, what does it look like? Now, I'm going to purposely leave some space in here. It's going to be multiplying, I'll change colors, the whole entire top by x squared, y squared. The bottom by x squared, y squared. I'm multiplying the top and the bottom. Why? Is because x squared, y squared divided by x squared, y squared is only what? What is something divided by itself?
0.
Not 0. 1. And 1 times something else is that something else. So it does not change the problem. Now to help us do this, and that's why I said there was some space in there, I'm going to actually multiply to the numerators and the numerator and denominator of the larger fraction, which in return only gets multiplied to the numerators of the smaller sets of fractions. So in my mind, or on my paper, I sometimes like to write is x squared, y squared over 1, because it's over 1, all over x squared, y squared over 1. Again, same thing divided by the same thing is 1, doesn't mean anything, okay? I'm not changing the value of this expression, but I am going to be able to simplify it and get rid of fractions. Now, hopefully you also recognize that, look at top, there's a plus sign. And when you multiply some number or some variables on the outside of parentheses that has pluses and minuses in it, you have to use the big D word and distribute. So therefore, I need to distribute all the way across. And think about it. Wait a minute. How do you multiply fractions? You multiply across. So that means overall it becomes 1 times x squared, y squared, all over x squared times 1. Right? When I go to simplify that and make an equal sign, what happens to the x squareds? I got an x squared on top and an x squared on the bottom. They cancel. The only thing left in the whole problem is y squared. Then I go back and do the same thing with the second fraction. What's going to cancel there? The y squareds cancel, just like the x squareds canceled. And then you get plus x squared. Moving to the bottom, what can cancel here? Because I have x squared y squared on top and an xy on the bottom. 1x and 1y. So an x and the square cancel. A y and the square cancel. So I'm left with what on the bottom? X, y. This is your answer. For some, you would say, that doesn't look any more simplified than the original problem. But here's the thing. There's no negative exponents. There's no fractions within fractions. So that is as far as you can go. Okay? Okay, so now what we're going to do is we are going to talk about simplifying square roots. And to simplify square roots, I always like to say go to the square root dance. Been using that for years. And the number one rule here is you must have a blank to leave for the dance. A date, or I like to say a...
That is false. Exactly, that's what I said.
This is a square root dance. You must have a partner. Okay? So, what does it mean? And we've done a couple of these. So, if I had a number like the square root of 52. That's a bad square root, 52. Okay? So let's do a square root of 52. This is the proper way to find your partners, is to take your number that's inside your square root and make a factor tree. Now your factor tree can look slightly different than someone else's, but at the end your result should be the same. You find all the prime factorizations that will multiply together to get you back to 52. So 52 is made up of what two numbers? 26 and 2. Now, the way I like to make my factor trees is I like to pull the smallest or the easiest ones to identify first. I looked at 52 and I saw it was even. All even numbers are divisible by 2. That's what I did. 26 is also even. Divisible by 2. 2 and what? 13. Is 13 divisible by anything? No. Only 13 and 1. That means it's a prime number. What about 2's? 2 is also a prime number, correct? So, what does it look like? Well, what it looks like then is that 52 is the same thing as the square root of 2 times 2 times 13. Now, this is what's officially happening, okay? Officially, that if I have numbers multiplied inside a square root, I can actually separate them to their own square roots by grouping them and sending them off. So this is what's going to happen. Without having to use the rules about grouping and pairings, would you guys be okay then with taking the two 2's and separating them to their own square root? Because we've already done ones where we've multiplied square roots together and I said, hey, you can multiply the numbers inside. Do reverse that order. Separate them to their own. Well, what's 2 times 2? 4. And so you get the square root of 4 times the square root of 13. And wait, the square root of 4, you guys would all say is 2. So this is 2 square root 13. That, ladies and gentlemen, is the proper way to solve or to simplify a square root. What I'm trying to say, though, is that we're going to simplify this process and say, instead of having to write them in their own square root, I'm going to do this instead. I'm going to say, hey, after I found out all my factors, I'm going to go back and circle partners. Because those partners, hold on, those partners are the ones that are going to leave or be separated from everybody else. And when they join together, they're just the number of the group. So those are a group of 2s. They become a 2. So it becomes a 2. 13 does not have a partner, so 13 stays home. It's there. Okay. Using the same process, please simplify the square root of 2,112.
What?
Same process. This process, we still have to find the prime factorizations. Now, unfortunately, this one's going to have a pretty long chain. So hopefully I don't run out of room. I'll try not to. But it ends in a 2, which means it's even, so therefore it's divisible by 2. So, take your calculator out if you need to. What is 2,112 divided by 2? 1,056. Wait a minute. 56 is divisible by 2, or it's an even number, so divide that by 2. 528. Hey, wait a minute, that's also an even number. So divide that by 2.
264.
264, and that is divisible by 2.
Why can't you just do 132?
132.
I'm running out of room.
Okay, now I'm hearing some people say, why can't we use larger numbers? Like, could I divide it by 8? Now, you can. But that means you're going to have a second branch coming off your tree. You have to be careful that you're always trying to grab the low-hanging fruit, I'm going to call it. Which means all of those 2s are hanging on their own. Okay? Okay? So you're going to have to grab those before you don't grab 528, because 528 was split. You grab the 2. Okay?
66.
And so, what is 2 and
66.
66?
And then 33.
2 and 33?
And then you're done. Yep, you're done.
No. 3 and 11. Okay. 3 and 11 are the last of the primes. So, now, we have a lot of numbers. Now, this is another reason why I necessarily like to do it this way, is because all of the numbers that I want or I'm talking about are right here. Those are all the numbers that I'm talking about. All of those 2s, which happen to be 1, 2, 3, 4, 5, 6 2s, and a 3 and 11. Here's the cool thing. If I feel a little lazy today, instead of writing it like we did over here, if it's nice and easy to read like this, they get to go to the dance. They get to go to the dance. They get to go to the dance. But the 3 and 11 don't get to go. So they stay home. How many 2s are going?
6.
Not 6. 3 pairs. So therefore, I have a 2 times 2 times 2 square root of 3 times 11. That's what it would look like, and then I clean it up. 2 times 2 times 2? 8 square root of 33. The reason why we simplify square roots, ladies and gentlemen, is because 8 times the square root of 33 is easier to read or use than the square root of 2,112. 2 times the square root of 13 is better than the square root of 52. Because 2 times 2 times 2 is 8. Multiply all your partners or your groups back together. Remember, when they leave, they become one member of that group, or one number of the group.
Well, you got that wrong.
Okay. Now, we also maybe I should probably put the rules on here. The rule that you are using in that first demonstration with the 2's to get 2 square root of 13, if I was to put a rule to it, and I'll erase it all so we can do this problem, is the fact that the square root of a times b can be the square root of a times the square root of b. That's a property of radicals. So they end up being the same root. So actually, if you really want to, you can tuck a little n in there for the nth roots. Okay? That'd be a little bit more universal for us, because we do work with other things in square roots in this class. Here's a cool thing, ladies and gentlemen. This whole square root dance can be extended to a cubed root dance, a fourth root, sixth root, eighth root, a hundredth root dance. All you're looking for then, instead of partners, is groups of 2 or 3 or 4 or 5 or 6. 100. And so it works. Now, the other one, now if you're looking at problem 4 there that we're going to need to know, you all of a sudden look at it and say, whoa, I've got a square root on a fraction. But remember, square roots or radicals are the same thing as exponents, right? They can be switched. And if I had an exponent on a fraction, I would take the exponent to the top and bottom. Yes? And so therefore, if I had, I'm going to leave this as the nth root. The nth root of the fraction a divided by b, I can just rewrite that as the nth root of a over the nth root of b. We're going to use that to our advantage now. And we're going to use the fact that if I multiply a square root of a number times itself, what happens to the square root? It cancels it, right? And it becomes the number inside. Guys, the square root of a times the square root of a should equal a, okay? We're going to have to use that in that problem. Okay, so now we're going to work on problem 4. So what I did was here is I made this larger so we could use it and work on it. And that is 3 times the square root of 3 over 2 minus 4 times the square root of 2 over 3 plus 2 times the square root of 24. We're going to take everything one step at a time. We're going to do one thing to each one of these parts at a time. So as I just had up there, if I have a square root of a fraction, I can square root the top and the bottom. Now, let's think. It's right now 3 times the square root. 3 really has what over it, or under it? It's a 1. So it can be used as a fraction in itself. So my first step, ladies and gentlemen, is to split the square roots up. So this becomes 3 times the square root of 3 all over the square root of 2. Can you visualize that? Can you see that 3 is really 3 over 1, so it's a fraction. And when I separate the square root up to square root of 3 and square root of 2, the 3 goes to the top of that fraction. Where would the 4 go? To the top. So it becomes 4 square root 2 over square root 3 plus 2. No, wait a minute. I have a square root of 24. 24 is on top. So all of that would be over 1. But do you think I could simplify that?
Oh yeah, you play.
2 and 12. 2 and 6. 2 and 3. Only one partner gets to leave, so it becomes 2 times the square root of 6. Yes, it would be a 2 times. The first 2 is the one that's sitting out already. I know, but Z would have a handlebar, remember? So right now, we have done one step of everything. So let's see. if I wanted to add those together, I would have to have a common denominator. Now, in the last problem, or one of the last problems we did, we said, hey, just find the LCD, multiply everything by the LCD, you'll get rid of denominators, correct? It only works if there's an equal sign. There's no equation here. So we actually should have to have a common denominator. But I really don't like square roots, and I don't like them necessarily in the bottom or in the denominator. So what I actually have to do is I'm going to have to, what they say is rationalize the denominators so they don't have square roots on the bottom. And that's again why I said the square root of a times the square root of a is a. What do I need to multiply square root of 2 by to make that disappear? Square root of 2. So guess what I'm going to do? If I multiply the bottom by square root of 2, I'm going to multiply the... I move to the second one, I'm going to multiply the top and bottom by...
3.
Not 3, but square root 3, square root 3. Yes? And then, we don't have to right now because we don't know what our common denominator is. It's going to change. I'm going to leave it as 2 times 2, which eventually will become a 4 for that square root of 6. So my next line, let's clean things up. We all know that square root of 2 times square root of 2 is going to become?
2.
So 2. What's the top going to look like?
3 square root 6.
3 square root 6. Because we're going to use that property that if I multiply 2 square roots together, I can take the numbers that are inside and multiply them. Because square root of 2 times square root of 2 is 2. Minus 4 times the square root of 6 all over 3 plus 2 times 2?
4.
Square root 6. Oh my goodness, they all have a square root of 6. That means they are all like terms. The only problem is you have 3 halves of one, you have 4 thirds of one, and you have 4 of them.
Multiply the bottoms by 2 and 3.
Right. Now, this is the point where I got to say I need to get common denominators. So now I have to do it all over again. What's the common denominator between 2, 3, and 1? 6. How do I make a 2 a 6? So it's 3. What I do to the bottom, I need to do to the top. 3 times 2. And this is really a 1, so I need to multiply it by, because it's 3 already, right? And 3 times 3 is, so it's 9 square root 6 all over 6 minus
6.
Why did you multiply by 3 on that side if you're trying to get the 2 out of the denominator?
the next one's minus 8 square root 6 over 6
Plus 24 square root 6 over 6.
over 6. Okay? And now, if they all have a common denominator, they all stay with the common denominator, and then I can put them all on the top of the fraction. Or, wait a minute, I have 9 of them, take away 8 of them, but add 24 more back of them.
So 23.
So I end up, what's 9 minus 8?
1.
1, and 1 plus 24 is
25.
25 of them, and them are square root of 6's. Then, you ask yourself one more question. Is that a simplified fraction?
No.
Can 25 divided by 6 be simplified?
No.
No, because 25 is 5 and 5, 6 is 2 and 3. They have nothing in common. I can't cancel. Somebody's probably thinking, why can't I just simplify the 6 and the 6?
Because it's in the square root.
It's a square root of 6, so you can't. That is your final answer. Your homework is on page 47, 7 through 10.
What's the 1 plus?
Correction, we already did 7 and 8, so let's change it up to 2. 9 through 11, and 21.